Welcome to this introductory video for the Microsoft Fabric tutorial. Introduction. Building end-to-end analytics systems has never been simple, and for most organizations, it's been one of the most difficult problems to get right. Not because the tools don't exist, but because they exist in pieces. Analytics platforms are usually made up of many separate services, each solving only a small part of the problem. There's one tool for ingestion, another tool for storage, another for transformation, another for analytics, and another for reporting. Over time, teams spend more energy stitching systems together, managing duplicated data across platforms, and maintaining complex architectures than they do creating insights or delivering real business value. This is the problem Microsoft Fabric was created to solve. Microsoft Fabric provides a unified end-to-end analytics platform that brings the entire data lifecycle together into a single, coherent experience. From data integration and storage in one lake to transformation, analytics, visualization, and a shared business model, everything operates within one platform on a single data foundation. Fabric is built from the ground up for modern analytics and the era of AI. Instead of layering new capabilities on top of fragmented systems, it takes an integrated approach where data, security, governance, and analytics are designed to work together by default. In this material, we'll start by building a strong foundation around the core concepts of Microsoft Fabric. From there, we'll gradually move into real-world analytics scenarios that organizations deal with every day, including lakehouses, data warehouses, real-time analytics, and data science workloads. Along the way, we will also cover the operational side of the platform, things like monitoring, security, DevOps practices, and how AI-driven capabilities such as Copilot can be used to increase productivity and streamline development. Who this material is for. This material is aimed at people who work with data and want to build modern, future-ready analytics solutions in the age of AI. That includes data analysts, data engineers, data scientists, data warehouse and ETL developers, business analysts, machine learning practitioners, software developers, and data leaders who are responsible for shaping analytics platforms inside their organizations. It's also a good fit for anyone with experience in SQL or Spark who's moving deeper into the data analytics space and wants to have a solid understanding of how complete end-to-end systems are designed and built in the analytics space. I will assume a basic working knowledge of SQL and Spark, but no prior experience with Microsoft Fabric is required. Everything is introduced progressively in this tutorial with a strong focus on clarity, core concepts, and how things work in real-world environments. What this material covers. To keep this journey practical and easy to follow, everything is laid out to move in a very deliberate way. From core concepts into real-world analytics systems and then into the operational and enterprise side of the platform. We start by setting the context. First, we will look at the broader analytics landscape around Microsoft Fabric and how it fits into the wider Microsoft data ecosystem. The focus here is on understanding the fundamentals, what Fabric is, how it's designed, and what differentiates it from other analytics platforms on the market. especially in terms of unification, simplicity, and modern architecture. Once that foundation is in place, we move into the different workloads that make up Fabric. This includes areas like data factory, data engineering, data science, data warehousing, real-time analytics, and Power BI. The goal at this stage is to clearly understand what each workload is designed for, how it fits into the overall platform, and how it aligns with different roles, skill sets, and organizational needs. This makes everything that follows much easier to understand. From there, our focus will shift to building complete end-to-end analytics systems. We will start with the lakehouse approach, walking through how a data engineer can build a full analytics solution using Spark-based skills within the Fabric environment. The emphasis here will be on modern data engineering patterns and how they translate into the Fabric environment. Alongside that, we will also explore the data warehouse approach. This shows how data warehouse professionals can design and implement an end-to-end warehouse solution in Fabric and how traditional warehousing concepts are supported and modernized within the platform. Next, we will move into real-time analytics. In here, we will look at how Fabric supports streaming and real-time scenarios using event streams and KQL databases. This includes understanding what types of data sources can be ingested, how streaming data flows into one lake, and how it can be queried, analyzed, and shared with other analytics engines. After that, we dive into data science and machine learning. This part will focus on how to build and operationalize machine learning models from start to finish, from ingesting and preparing data to exploratory data analysis, model training, tracking, and deployment. Both batch and interactive scoring scenarios will be covered, showing how models fit into real analytics workflows. Once solution design and implementation are clear, attention turns to monitoring and operations. This includes monitoring pipelines, Spark jobs, data warehouse activity, and real-time analytics workloads, as well as understanding capacity usage so performance and cost can be managed effectively. We will then move into administration, focusing on how Fabric is enabled and managed at scale. This includes tenant-level configuration, capacity management, workspace associations, and how tenants, capacities, and workspaces fit together, all essential for running Fabric successfully in enterprise-scale environments. Security and governance will come next. This covers how security is handled at the tenant, workspace, and item level, how external access is managed, and how governance tools such as Purview and data domains can be used to organize, catalog, and protect data across the platform. From there, we will look at DevOps practices, including how continuous integration and continuous deployment are used to move Fabric items across environments like development, test, and production. Finally, we will explore AI assistance and co-pilot integration across Fabric. This includes how AI capabilities are embedded into different workloads to boost productivity, speed up analytics tasks, and provide deeper insights, along with what's required at the tenant level to enable and manage these features.